My iPad too, so we have to share our screen in a slightly different way. So if uh if it takes a little bit longer or if something looks a little different, that might be why. Otherwise, welcome. Let's go ahead, take a look at our sort of agenda for today. Present. All right, gonna look through Schoology review. I'll kind of explain, kind of like an icebreaker, extra credit activity. You're more than welcome to participate if you'd like. We'll jump into kind of like our week 6 review. Again, hopefully you've had a chance to look at the materials so far this week. Additionally, there you'll notice that it's a pretty short week, so we're gonna kind of be wrapping this up with a quiz. Hopefully you guys will take it either this afternoon or tomorrow. Then we'll get some chance to practice and then we'll recap and look at our Class Connect. I believe we've got a friend who is joining. Perfect. All right, now let's take a look at Schoology. All right, so again, as we look through our class page, we've got our week 6. Like I mentioned, it is a shorter week. So because it's kind of a shorter, this whole unit's about what we call is like logic. And it's kind of giving us the stepping stones to becoming able to write geometric proofs. And again, that's a very useful skill in life to be able to sort of explain your thinking, to be able to rationalize what you did with facts or with what we'd call logic and deductive reasoning. So very applicable to not just in math, but any sort of aspect of life. But we will continue to build on this later in the year with something called geometric proofs. So the first 2 lessons are kind of combined. Again, they weren't very long, small little assignment. IXL is probably going to be your best practice for these. Again, if we look at it, these types of logic problems can be kind of tricky to like come up with a lot of examples, but that's where IXL is great, is they discuss or they give you lots of different practice examples. So again, as you work through them, you can say, oh, I think I know a counterexample to this. If a solid has a rectangular base, then it is a rectangular pyramid. Well, that might not be true because a triangular prism has a has a it doesn't have a rectangular base, but a rectangular prism has a rectangular base, and that's not a pyramid. So that would be your counterexample there. All right, let's keep going. So yeah, after our Schoology review, you'll see that we are going to do a test or a quiz at the end of this unit. Like I said, it's a very short unit, so we started it and we finish it this week. Sometimes it's nice to have those quick units, again, kind of wrap up. As far as looking ahead, next week is a short week. So I believe that there will be, yep, just 2 lessons. So one for Monday, one for Tuesday. If you're all caught up and ready to go, use MEA break. I hope you have a great break. If you're not caught up, that's a great couple days, like a long weekend, to really try to get some of that missing work turned in. And again, it's a very small kind of workload assignment for us that week. I'm going to share this. That way, if any of you want to work ahead, okay, so if you're interested and hey, I've got a trip coming up, maybe, go ahead, type in the chat if you have any plans over MEA break. Again, that's not this week. That's next week. But if you got anything planned, I know I've got a football game on Wednesday, and then I'm going up to one of my good friends' weddings in Brainerd on Friday. So I'm going to be making a little bit of a trip. I hope the leaves are still nice. I don't want them to all fall off, but I'm worried that with the cold weather coming in, I'm worried that the leaves are going to start falling. All right, so your respect extra credit opportunity. If you remember, we do kind of like our school does this thing called Character Strong. We kind of talked about it last month. This is something where we just try to focus on an important characteristic each month. This month it's respect. So I wanted you to, again, just kind of to think about it, have a what does respect mean to you? How do you show respect? How do you earn respect? How do you give respect to other people? And just kind of, open our eyes to sort of things that are happening around us. So if it doesn't have to be today, could be this week, could be over MEA break. But if you find 5 instances where you see someone demonstrating respect, could be a parent, a sibling, a cousin, a friend, someone, random person at the store, whatever you do, just type me up a quick recap, a couple sentences of what those situations were and how that how did that make you feel? What did you think about? Were you able to replicate it to someone else? And I can add that onto your quiz for this week. So again, out of 50 points, 1 extra credit point, that's 2% on your quiz. So again, free 2% boost on your quiz if you email me 5 examples of respect that you see throughout your life. Okay. Any questions on that? Let me check the chat. Any questions on that before we jump into sort of the next part of our day, which is reviewing inductive and deductive reasoning. So again, you've probably heard these words before, but maybe they didn't make a whole lot of sense to you, or you just never really thought about it. So deductive, again, I kind of like to think of like it as like a detective. You are rooted in the facts. So you kind of have to stick with what is known. It's more special than the information the premises provided. It is reached directly by applying logical rules. Whereas inductive, I'd kind of think of it as more of like a lawyer, where you're given some of these facts and you have to kind of, hey, this could have happened, or hey, this could have happened, based on observations of specific cases. So deductive is like you're working big picture and working down into something that is, hey, I know that this is to be true because of X, Y, and Z. Whereas inductive, you might be like looking at a real small situation and saying, hey, it rained last week on Tuesday, therefore it rains every week on Tuesday. Now, again, sometimes, like that example, it's not always going to be true. So, again, if we think about, does it always rain on Tuesday? No, but sometimes it does. And so if we look at like our usage, deductive kind of takes a little bit more thought, takes a little bit more effort to be like, yes, this is true, or no, this is true. Whereas inductive, we use it all the day, all the time. Hey, it looks cloudy. I think it might rain. Or, I've been spending a lot of money lately. Maybe I should save. Versus deductive would be like, no, the weather report says that it is not going to rain, therefore it's not going to rain. Or inductive would be, no, according to my monthly budget, I have $42 left, so I can still spend $42. So we can kind of use these in a sort of a variety of different ways. Geometry is a lot of vocabulary. We've talked about this throughout our first couple units. And so again, if you don't understand the vocabulary, you're really not going to know what to do. So a conjecture is just basically something that's stated, something that's said. It's based on observations, and we don't know if it's true or not. It's just basically a statement. Anyone can say anything. Well, how do you prove that conjectures are false? And one of the easiest, one of the best ways to do that is through a counter example. So if you can find one counter example, you can prove the whole conjecture to be true. So take, for example, that statement I said earlier, it rained last Tuesday, so it's going to rain every Tuesday. All you'd have to do as a counterexample would be to find one Tuesday where it did not rain, and that whole statement becomes false. So again, as far as like being, we talked about detectives versus lawyers. Detectives would find that example and say, all right, we can't operate under that circumstance anymore. It's not, our deductive reasoning didn't apply it. The lawyer could be like, hey, wait a second, my client didn't do it. It didn't rain 4 Tuesdays ago. They must be innocent. Something like that. Oftentimes we talk about logic, especially in geometry, our class, as conditional statements, which are usually in the form of an if then. So, and we kind of call the if part the hypothesis and the then part conclusion. So let's see here. If the temperature is below 32 degrees, then it may rain, or then it could snow. If the temperature is above 32 degrees, then it will rain. So again, there's a difference between what's our hypothesis, if this happens, what's the effect? What happens sort of after that? So there's two kind of big laws that we talked about. The law of detachment and the law of syllogism. Now the law of detachment works like this. If the hypothesis is true, then the conclusion is also true. So if P is true, then Q is also true. So if I look at this example, if a figure is a triangle, then the sum of its angles is equal to 180 degrees. So if I look at a situation, figure ABC is a triangle, yep, then the sum of all of its interior angles, x plus y plus z, we know that triangles always have 180 degrees. So that would be a true statement because once we know it's a triangle, we know all these other things about triangles that happen to be true. So what can you infer from the following two statements? All chickens hatch from eggs, and the other statement, Betsy is a chicken. I want you to take a second to think about it and maybe type into the chat what's something that you can infer from this statement. Betsy lays eggs. All chickens hatch from eggs. Betsy is a chicken. You I could see where you'd get that. I would say that, let's see here. All chickens, Betsy is a chicken. All chickens hatch from eggs. Therefore, Betsy lays eggs. Yes, absolutely. So what we're trying to think about is, hey, I can kind of cut out this middle part here. Betsy is a chicken. All chickens hatch from eggs. There I can either say Betsy hatched from an egg, or that would probably be the more specific explanation would be, well, if all chickens hatch from eggs and Betsy is a chicken, we could say that Betsy hatched from an egg. When we flip them around like we did, okay, like we can, if we flip them around, that's called um there's the contrapositive, and we'll get into that stuff in a little bit. Okay, so again, when we get into more of those proofs, we can flip-flop hypothesis and conclusions. We can make conclusions and hypothesis either the positive or the negative version, and then that does tend to change some of what we're thinking. And this was the second law that I was talking about, which basically works if you have multiple parts. So if A, then B, and if B, then C, and if all of that's true, then we can say A, then C is also true. So really, what we're doing is kind of cutting out the middleman here. So let's take a look at a geometric example. If two segments are perpendicular, then the segments form a right angle. If the two segments form a right angle, then they can be a corner of a rectangle. And if two segments are perpendicular, then they can be a corner of a rectangle. So really, I can kind of think about putting all these things together, and I could say, if two segments are perpendicular, then they can be a corner of a rectangle. It would be possible for them to be a corner of a rectangle. Does that mean they are? No, but it's possible. It would be logical. All right, so again, I want you to think about this one. If you make a right turn, you must use a turn signal. There is a right turn on the way to school. What can be inferred from these two statements? Think for a second, type in the chat once you think you've got an idea. Oops. You must use a turn signal. Definitely on the right track. If you make a right turn, you are on the way to school. Again, I think you guys are bold. If we could kind of combine those things, you must use a turn signal on the way to school. Yes, exactly. So the first sentence, I basically think about, hey, if I need a right turn, I must use my signal. So I'm thinking right to signal. Then it says, okay, if there's a right turn on my way to school. So I have right to signal, and then I have on my way I use to school, I use a right turn. Therefore, if I go to school, I must use a turn signal, or you must use a turn signal on the way to school. So those are things that we can infer using this law. Awesome job with that. Again, I think these are super cool. Logic and stuff like that is something that again, as far as branches of math go, I think it's super cool. I also think it's almost the more, oops, hold on a second. The more you think about it, it's almost the harder it gets. So that's where, again, in my mind, these logic puzzles and these types of things, if you just think about it and kind of take it at face value, you can usually kind of guess it because we use it all the time. We use it every day in our lives. Okay. I'm going to post a link in the chat and then click that. Let's get some inductive versus deductive practice. All right, link's been posted. Go ahead. Let's get some inductive versus deductive practice. And then we'll meet back in about 4 minutes or so. Okay, so again, click that link in the chat. Go ahead, join that. All right. For those of you that are watching the recording, I'm going to share my screen and then you can just kind of pause the video and try those on your own. All right, let's go about 1 more minute. Again, I know you're not going to finish, but just to kind of respect your time and to keep moving along. All right, let's go ahead and wrap up the question that we're on so that we can recap, talk about our Class Connect assignment, and then send you on your way. Okay, let's see if there's any ones we want to go over real quick. Number 3, number 8. All right, let's take a look at number 8 real quick. The sum of the interior angle of a square is 360. The sum of the interior angle of a rectangle is 360. The sum of the interior angle of a parallelogram is 360. The sum of the interior angle of a rhombus is 360. What is the possible conclusion based on the given information? Again, it wouldn't be exterior angles because all of these talk about interior. And again, this answer is not quite specific enough. All of these talked about four-sided shapes: square, rectangle, parallelogram, rhombus. All of these have four sides, which again is kind of like the definition of a quadrilateral. It has four sides. And not that one, not the single interior angle, but the sum, all four interior angles added together. All right, I think there was one more. Let's look at 11. All right, let's take a look. How many dots are in the next pattern? So again, if it looks like each pattern, I'm adding one more on the top and one more on the bottom. So that means that this next one would have, let's see how many we have here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that means I'd add 11, 12, 13, 14, 15. I'd add another row of 5, okay? So I'd add 5 dots to this next row, which gives me a total of 15. Yeah, pretty good job with that. Your Class Connect assignment, again, if we go to our folder where it's always located, I'm going to publish it so you guys have access to it. Remember, I also published week 7, so if you do have a trip coming or you want to work ahead, if you don't, no worries. Oh no. Let's pick the one that we just did. Okay, let's go with this one. How many dots are in the next pattern? And the answer is going to be 15. Apologize about that. It must not have saved when I put it in there. Oh, desktop. There it is. Okay, let's see here. 1, 5, 10, 15, and 20. And again, our answer is 15. All right, apologize about that. That must not have saved when I did that last, but go ahead, answer that. Again, the correct answer is 15. We did it together. And you will be excused for the day. Okay. Have a great rest of your day. We do not meet next week because it's a short week. So let me know if you have any questions. Go ahead, make sure you get Unit 2 completed, and I will see you in a couple weeks. Have a great MEA break. Bye, everybody.